Hi, welcome back to another video. So in this video, we are going to solve a practice problem in order to practice our learned concepts in our previous video. That was the operator overloading, unary operator overloading, as well as binary operator overloading. So in this video, we are going to create a complex number class. And why do we want a complex number class? Let's have a look at the background. Okay, so first of all, let's say if we have a integer quantity like 1, 2, 3, we can use an integer data type. Let's say we have 1.2 or 2.3, which 3.3, which means it is a decimal number, so we can use a float. Okay, it's right. So what about the complex number? Complex number is basically the combination of real numbers as well as imaginary numbers. So what are real numbers? So real numbers are any number like decimal point containing number or integer number. So it is fine. But what about the other part of the complex number? That is the imaginary part. It has an entity that is called iota, which is equals to I is equals to under root of 2. So under root of 2, basically it is equals to under root of 2. Now when you have under root of 2, sorry, not under root of 2, under root of minus 1, I'm sorry for that mistake, iota is equals to under root minus 1. So when you have this part in your number and combination of this part and any of the above, that is called the complex number. So the general form of complex number is a plus b iota, or in some cases it is also represented by j as well. Okay, so as you guys can see that the complex number is the combination of two quantities. One is the real quantity and another is imaginary quantity. So for that reason, we, let's say we do not have any kind of specific data type that can represent the complex number as well as perform some operations over it. So if we just created before, let's say if we didn't study this lesson 9 operator overloading, we would be still able to create the class of the complex number. But the actual thing is the performing operations over a number. What do we do in mathematics? We multiply things, we divide things, we add things, we subtract. So for that reason, we needed the concept of operator overloading. So in this practice problem, you will also practice on the creating class, accessing it. So that is also your previous topic, as well as operator overloading, performing some operations on the objects of the same class. Now let's create a class by the name of complex first of all. Okay, so we have a class by the name of complex. Now in complex, what do we have? We have one real part and another is the imaginary part. So these two quantities, these two numbers can be floating point as well, like 1.3, 1.2. Okay, so in case if someone enters a number that may have a decimal point, so for that reason we will keep everything as a float data type. Okay, so we will say float real part and float imaginary part. So now we have got two member variables. One member variable is representing the real part of our complex class and another is representing the imaginary part of our complex class or complex number. Now these were in the private section. Now what do we want? We want in public section a constructor. Okay, so one constructor will be an empty constructor as usual. Just in case if someone doesn't want to send parameters in the object, so then this empty constructor will be called. So in case of empty constructor, we will have real is equals to 0.0 and imaginary is equals to 0.0 as well. Okay, and next thing that we are going to do, we are going to have a parameterized constructor in which the user, if the user wants to send some value or initialize or assign some value to its complex number, so the user can do that as well. So what do we want here is the float real, or we can say real, and float imaginary. Okay, and we will do this. Real is equals to real, received real, and this imaginary is equals to imaginary copy received. Okay, so we have got the parameterized constructor over here as well. Now let's create a display function with the help of which we can display the uh, this real number, so in a good representation. So we will call it as a display function, and within the display function we will say cout. We will write this as a real part, so we will say real, and then this. So within the operator, what are we going to do? We are going to write a sign that will denote the addition. Okay, so we will just write a plus sign over here, and after that what we going to write is the imaginary part. Okay, yes, we got the imaginary part. Now what I am going to do, I am going to rearrange in such order that it should look like good. Okay, it looks better. Now what I am going to do, I'll just enclose this imaginary part within the bracket. Maybe the imaginary part may have a minus sign, so plus into minus, that will have some effect. Okay, all right, so we have this, and I guess we are good to go, and we will print in endl. Okay, so first of all, let's just represent this with some. Let's see what it looks like. Okay, so let's create a complex num1, and we will pass 3 and 6. Okay, and let's print out the num1 dot. Sorry, what is this? Display. Okay, all right, let's run this code. I guess it's not looking that good. One thing that I have to change is the space, and another thing that I must add over here is the I. Now let's see. I guess it looks much better in my opinion. Okay, 6 iota. So because what is the purpose? Maybe you will be asking what is the purpose of this plus sign or these brackets. Let's just remove this, okay, and then print out. So what is this? 46i. So it's not giving you that good, like, good representation of a complex number. So we will just control plus Z it, and it looks much better. So what will be the advantage of this representation? That we will get this kind of representation, 4 plus into minus 6 iota. Okay, so that is good. I guess that is good. Nothing come over. All right, so let's design a display member function which is going to display these members like a real number and imaginary number as a combination of these two uh, to result in a good printing result of a complex number. Okay, so which resembles this kind of appearance. Okay, so let's do that. So for that purpose, what we are going to do, we are going to have a display name function. Okay, and after that the simple thing is that if I want to do it C out and let's print real and imaginary with some space and imaginary and then ended. Okay, and after the imaginary we must have iota sign. Okay, so we will have I. So is this good representation of the complex number? Let's find out by creating an object of this class, which means that we are creating a complex number. Okay, complex num1 and num1. Okay, I should pass some parameters. I will pass 2 and 6, let's say. And I will print this complex number with the display function. All right, so let's print out the result. Let's print out. uh, there is some problem at the end of what. All right, so we have accidentally removed the brackets of our class. Okay, let's run this code. Okay, so is this a good representation? No, because it doesn't give us a good idea of what's happening, what's going on. Okay, so let's print in a different syntax and different representation. Okay, so I'll just quickly write that format for you and then I'll explain the code. Okay, let's go. All right, so I have designed some code that will give us a really good format of our complex number. Let's print out our result again. So as you guys can see that it looks much better than the previous representation. And if I pass a minus sign over here, what this format will do, it will rearrange it in such order. Okay, so I'll just remove this minus sign from here. Now it will be right. Okay, as you guys can see 2 minus 6 iota. So it clearly shows that the real part is positive and the imaginary part is negative. Let's have both negative. So we have got the perfect format for the our complex class. So our display function is designed. So let's print the data with the 0 as our imaginary part. So let's have a look. So we will have this, and as we run it, it shows minus 2 and 0 iota. It is good. It is not bad. It is not bad representation. But what we want that if there is no imaginary part, it should show the only real part. So it shows that this format showed that we are entering into this if. So we will have another AND logic with it that if the sign times imaginary should not be equals to 0. Okay, then you should enter. Now if I print this, it will have only real part. So now it is the actual in representation, the format style of our complex number as you deal in your mathematics as well. So all right, our display function is successfully designed. Let me just show the code and tell you that what each step does in this code. Okay, so first of all, I have a simple variable that is a positive one. Okay, so why I am having one? Because one is multiplied with anything, it has no effect unless only the change on in sign can take effect if the another quantity sign is changed. It's simple mathematics. So I have a condition: if sign multiply means that 1 multiplied by imaginary is greater than 1, that means a positive imaginary part, then print it in this format that it will have a positive sign within these two quantities, real and imaginary. Then if the multiplication is less than 1, that means the imaginary part is minus, and it is not equals to 0, that means the imaginary part does exist as well as it has the quantity less than 1. So print it as it is. because the minus sign automatically gets with the number. Okay, so if the number is negative, then I have else condition. Else means if none of the above conditions are met, that means if not is greater than 1, it is not less than 1, that means it is equals to 0. So just print the real part of our complex number. So this is the code for our representation or the format for the complex number printing. Okay. Now, what are we going to do? We are going to have one operator overloading that will be used to add two complex numbers. Okay, so let's have an operator overloader. So the style or the syntax for it is that we want to have a return data type. Why? Because we have discussed it in our detail in our previous video. Okay, just like function, we want the return data type over here as well, and we want to overload the plus operator here. So if we are dealing with the additions of two objects, that means we are going to receive a parameter, and we will create the complex class parameter and with the help of reference and by the name of temp. Okay, this is just a simple syntax. And what we are going to do, we are going to have another temp complex capital temp. Okay, so temp dot real part will be equals to real. Okay, so this real represents the object real, so that means the number 1 real, which is the first parameter received automatically, plus the reference that is received over here, that real part. Okay, so real again. So we have the addition of both real parts, and now we will have temp dot imaginary equals to imaginary plus temp dot imaginary part over here as well, and then we will return our this capital temp. Okay, because as we stated that we are returning a complex class and temp is the object of data type complex. Now what we will be able to do, that let's say we have another complex object, so complex object, so num2, and we should have, let's say, 3 and 5. Okay, and we will have num1 is equals to num1 plus num2. So that means add both of these numbers and store the result in num1, and we will display the data. Okay, let's have a look. We have got 1 plus 5 iota. How? Let's see. We have here 3 plus minus 2, which means we should get minus 2 plus 3. What should be the result? Minus 2 plus 3 is equals to 1. That is correct. And the 5 plus 0 will give us 5. Yes, this is totally correct. So our addition is done. Now you will design some same kind of subtraction. So you will have num1 minus num2. Okay, so the sign will be changed. That is going to be your assignment. One more operator we will overload over here that we haven't done in our examples as well. That is going to be the multiplication. We are going to multiply two complex numbers. Okay, so constant, other things will remain the same, complex, and we will have temp. Okay, any other thing will remain same, but only thing that is going to be changed is that we will be applying the logic of our what do we call it, logic of our multiplication. All right, so this is the logic that we are going to use. So for example, if we have two complex numbers like a plus b iota multiplied by c plus d iota, so we can do this in this way. So a into these two and b iota into these two. So a times c is ac plus a times d iota is equals to ad iota. Then we have got b iota multiplied by c is equals to c b iota, and then b iota multiplied by d iota is equals to b d iota square. But actually iota square can be equals to, it is equals to -1. So for that reason we have removed iota square from here and we have replaced iota square with the minus sign. Now these, the without iota numbers are our real numbers. Okay, so AC minus BD is our real part and AD plus CB into iota is our imaginary part. So this is the concept that we are going to implement. Now, let's say that the returning class is this and the receiving parameter is also this. It is not just let's say, it is actually like this. Okay, so let's design a function now. Temp and not sorry, just temp dot real. So real part is this one. So let's implement this in our code. AC minus BD. All right, okay. AC minus BD. That means that multiply A multiply by C. So what is A and what is C? So A is the real part of one object and C is the real part of another object. So we can say a real multiply by temp dot real. Okay. So this is our first thing that we have done. Now, what is the next step? Next step is A multiply by D iota. That means not sorry, A multiply by D iota, but B multiply by D iota. We have to look at this real part. Okay, so I'll just write R, and there is already I over here. So we have to multiply B, that means the imaginary part, the imaginary value of one with the imaginary value of another, but with a negative sign. So that means that we have to get minus, and then imaginary part of one object multiply by temp dot imaginary part of another object. So now next thing for our imaginary part, what is A multiply by D? So A multiply by D. So first of all, let's write temp dot imaginary. Okay. So we will write, so what is A? A is basically the real part of object 1. So we have to call it as real. Okay. Then we have to multiply it by D. So what is D? D is the imaginary value of the another, what is called that imaginary part of the another number. So temp dot imaginary. Then after that we will write plus, and we will write what is it? It is C times B, which is C is the imaginary part of first object, so which is IMG, and it is multiplied with B. Sorry, C is the real part of temporary object, temp dot real part, and it is multiplied with B. So what is B? B is the imaginary part of the object 1. So I got it right before as well, but just let's follow the rules. So for just your understanding, let's just decompose our this into these variables. Okay, let's decompose it so you will understand it more better. Okay, so let's say that the real variable name is equals to A, and IMG is equals to B, and where is the other thing? Temp dot real is equals to C, and temp dot IMG is equals to D. So these are the variables. So we are doing mathematics today in our tutorial. Wow, nice. Okay, so let's go. Okay, so A is real. So what we should have, the first part, the real part should be A times C minus B times D. Okay, So A times C should be real time temp dot real. So real time temp dot real, that is correct, minus B times D. So B, what is B? B is imaginary, imaginary is correct, and D is temp dot imaginary, that is correct as well. Now for the imaginary part, which is this one, we should have A times D, which is real time real multiply by temp dot image. So what is temp dot image? Temp dot image is a, yes, it is D. So that is correct as well. It is equals to A multiply by D. And this one should be C multiply by D. So what is C? C is temp dot real. That is correct. And imaginary, what is imaginary? Imaginary is B. Okay, that is correct. So we have achieved our result, and then we will return the temp. So you guys see that this is going to be a good practice for you guys. Practice of mathematics, practice of logical thinking, practice of how you should put things together. Okay, so now instead of adding them, let's multiply them and let's display the result. So we have got minus 6 minus 10 iota by multiplying minus 2 plus 0 iota with a 3 plus 5 iota. Now I will do the calculation over here in my ref register. Okay, so just to be on a safe side, I will just quickly do the calculation. You guys should do it with me as well. So we have got minus 2 plus 0 multiply by 3 plus 5 iota. Okay, so I'll have the formula on the screen, this one. So perform the multiplication according to this. Okay, what should be our result? Okay, let's say, okay, minus 2 multiplied by 3 plus 5 iota and plus 0 iota into 3 plus 5 iota. Okay, so minus 2 multiplied by 3 is equals to minus 6, and minus 2 multiplied by 5 is equals to minus 10 iota. And due to the second part, 0 times 3 plus 5, so we have got 0. So that means minus 6 and minus 10 iota is going to be the right answer. And as you can see, this is correct. So this was it, the operator overloading practice. We have got our complex number in our C++ language. Now you can add two complex numbers, you can multiply two complex number, you can also make another operator overloading. The assignment for you guys is going to be the subtraction and division, and the division part is going to be interesting. Okay, z1 divided by z2 is not just a simple division, you have to do something in it. So go and implement that in this, and you will get a lot of things to learn in your practice. Okay, so I hope you guys have understood this tutorial, and I hope so you guys got the idea of operator overloading in this class. Okay, so I'll meet you guys in the next video.